Hey everyone, and welcome to Dr. Abu RTN Academy channel. Today we are going to discuss part 8 of the sets and the probability and biostatistics. In this video we are going to start with the marginalization. Marginalization, the word marginal means that I have a combination. For example, A and B combined together, intersection or union, and I want to get out one of them. I get A only, or I want to get B only, so I get one margin. For example, if you have a page, I want to get a slice only of this one, this slice called a margin. I'm getting a margin of it, okay? So marginal, I'm getting part of it, okay? So marginalization means I want to find one of the events or one of the criteria which I have. So this is the meaning of marginalization. So here, if events B1, B2, B3, B4 up to Bn, or whatever number of B's, whatever number of events, 4 events, 5 events, 10 events, 3 events, whatever, are mutually exclusive. We said mutually exclusive means that they are independent. There is no intersection between them. Every one of them doesn't depend on the other. Okay, there is no overlap between them. They are disjoint. This is the meaning of mutually exclusive. So there is no intersection. They are disjointing. Okay? Okay, so if the events P1, B2, B3, B4 up to Bn are mutually exclusive pairwise, so each pair of them, so P1 with P2, let us talk here. This is P1 and this is P2. There is no overlap between them here. So B1 is here and B2 is here. There is no overlap between them, okay? Mutually, this one and this one are mutually exclusive, pairwise, this pair. And if I have B3 here, also they are mutually exclusive. There is no overlap between them. So each pair, this P1 and P2 as a pair means 2 as a pair, they are mutually exclusive. B1 and B3 as pair, they are mutually exclusive. This is the meaning of pairwise, each pair of them. So P3 and P4, they are mutually exclusive. Okay, so each pair of them, that's why it's mentioned here, pairwise. Okay? Okay, so here they are mutually exclusive, pairwise. So each pair of them are mutually exclusive. And the sum of their probabilities is 1. Always the sum of the probability, if we have all the events and all the probability, the sum of all probabilities, it must add up to 1 if it is the full probability, okay? So the full probability is 1. So if I said I have blood group A and blood group B, blood group C, blood group A, blood group B, blood group AB, and blood group O, so there is no other chance. So the total probability of these 4 blood groups A, B, and O is 1, okay? So the sum of the probability is 1, so they are full. And BI means B1, B2, B3 not equals 0. So none of them, it's a probability 0. So probability of P1 is not 0, probability of B2 is not 0, probability of B3 is not 0. Why? When we see the probability of anything is not equal 0 in the question, this means that it might be in the denominator. If we divided anything by the probability of B1 or B2 or B3, if it is 0, it will be a problem. It will give us infinity, so it cannot be. So when we see the probability BI 0, not equal 0, this means that it might come in the denominator, okay? Okay, so let's continue. Exclusive pairwise, and the sum of their probability is 1, and B, the probability of BI, not equals 0. Then the marginal probability, the probability of one event, like probability of A, probability of X, probability of Z, probability of Y, anything is. So before coming to this formula, it is better if I can better explain the graph which we have down here, so it will help us to understand the concept of this marginalization. So, for example, if I assume that B1 represent Hungary, one country, B2 represent another country, Egypt, for example, B3 USA, B4 UK. So we have B1, B2, B3, and B4. Each one of them represent a country. Okay, so if I have one disease A, so the probability of A here, this is an event which will happen to any of these events. So we have an event which having one country, Hungary, another country, Egypt, another country, USA, the fourth country, UK, and you have a disease which is another event, okay, which is a disease, for example, a disease, which is A. So B is the country and A is the disease. So here, this is the probability of the disease A happening in Hungary, in P1. Okay, so this is the probability of the disease A happening in B1, which is Hungary. And this is the probability, this circle, the probability, in this case they are equally distributed. The disease A happening in Egypt, the disease A happening in USA, the disease A happening in the UK. So what is the probability of the disease A happening? It is the sum of this probability happening here, and the probability happening here, the probability happening here, the probability. So all of them, the probability of the disease happening. So this is part of the overall. So this is the overall probability of the disease A happening. Okay, so disease A occurs, and this is the total probability. But it was a split. The probability in Hungary, the probability of the disease A in Egypt, probability of disease A in USA, probability of disease A in the UK. This is the overall probability of the disease A. It is split. So what is the probability of the disease A in total, overall, the sum? It is the sum of the probability of ABI. What's ABI? I means can take from 1 up to n. 1, in our case, it will be from 1 to 4. Because we have 4, B1, B2, B3, B3, and B4. So it will be from I equals 1 up to I equals 4. In general condition, it will be from I to n. But in our example here, it will be from 1 to 4. So B1, AB1, sum of them. AB1 plus AB2 plus AB3 plus AB4 and so on. Okay? So, what does it mean AB1? If you can see here, this is the intersection. This is the intersection of the disease with the country. Okay, so this is disease A intersecting disease A intersecting with B1, which in our case was Hungary. Okay, which we can write it A B1. Okay, and this one, disease A intersecting with B2, which we are writing here A B2. Okay, and so on. So the probability of disease A happening, the overall, is the sum of this one. So it is the sum of means everything here plus the next one, the next one, the next one, until we reach n. Okay, so it will be probability of A B1 plus again the probability of A B2 plus the probability of A B3 and so on until we reach n. Okay, so the sum from I equals 1, okay, to I equals 4 in our case, or it could be n, 5, 6, 7, it depends on the case. Probability of A B I, and I will take, sorry, I is equals 1, starting from 1 up to 4. So I will take any value, so it will be in probability A B1 intersect. Just keep in your mind that probability AB1 means A intersect B1. Okay, it is the same thing. AB1 means A intersect B1. A, the disease intersection with B1, this area. Okay. Okay, so coming back to the question, so the probability of ABI, okay, equals AB1 plus probability of AB2 and so on. So if you remember from the last slide, we said the probability of AB1 or intersection or the probability of A intersecting B equals what? We said it's equal the probability of A given B multiply probability of the last one, which is B. Here also it is the same thing. Probability of A given B times probability of B, the same thing. Okay, this is what happened here. So just he expanded. He left the sum notation here. Probability of ABI, he just put it in the form of given. Okay, so it is the probability of ABI equals the probability of A, the first one, given, which is the intersection, BI, okay, times probability of the last one, BI, in the same way. There is nothing different, okay? So this is the disease, this is the overall probability, just again, A, you can see here, this is A, the probability, and this is it's a distribution. So the probability A, if we add it, this is 100% of the diseases which is distributed among the 4 countries, okay? So probability, the disease in the country 1, the disease in B2, the disease in B3, the disease in B4, and so on. It will be clear when we start taking some examples. The next slide is one example. So in this example, we need to concentrate. This is an example on marginalization, okay? Please concentrate to understand how to realize that this is a problem of marginalization. In this problem, it is the opposite to the conditional probability. It is opposite to the conditional probability, because there we are getting individuals and we won't find the conditional probability of A given B or B given A. But in this marginalization, we have the conditional probability, which is the combination, and we need to find one individual of them, okay? So here what he said, in a population, 4% of women B1, woman, and they call the woman B1, 4% of the women are affected. So I have 4% affected, and they are women. So woman is given. So woman, it's given. So here this 4%, what is it? This 4% or 0.04 or 4% is the probability of the affected people for the disease A, given that they are women. So this is the probability of the affected disease, the probability of the disease A. Probability of A given that they are women. Woman, I can write it W, but here in this example, he gave it me as B1. B1, okay? So this is the 4%. And 6% of men, so men also is given, 6% are affected. The same way of reading it, 6% are affected and are given that they are women. So this 6% is 6% of the disease. Okay, 6% of the affected by the certain disease, 6% having disease A. So this 6%, 0.6 is the disease A, the probability of the disease, given that they are men, B2. Okay, so this is the 6% and this is the 4%. Okay. So the 4% here in this example is given that they are the woman, but this 4% is not for the woman. The 4% is for the disease, the affected people. 4% affected people, so A, but given that they are women. And 6% also not the percentage of the men, the 6% of the affected people with the disease A, given that they are men. So the 4%, I can write them as the 4% is the disease, because 4% represent the disease. It doesn't represent the woman or the men. The 4%, the people affected, okay? So 4%, this is the probability of what? Of the disease, which is right. So the probability of the disease is 4%, but given that they are women. The probability of a what? Of the first thing, the probability of A is 6%, given that they are men. So the probability of the disease is 4%, A, given that the woman equals 0.4. The probability of the disease given that the men is 0.6. How also can I recognize, or to make sure it helps us actually in some cases, that the probability of one event given other event, usually it is very small, like 0.1, 0.15, 0.02, 0.03, which is very small, not 70%, 60% usually, okay? So also it can guide us, okay? So this 4%, it is the given probability, okay? So what is the probability of the women themselves, the fraction of the woman in the population? So this is the fraction of the woman is 53%. Here in Debrecen, they're using the word fraction to represent the percentage as well. Okay, so he can use fraction here as decimal, 0.53 or 53% or 53 over 100 for the people who are, or the students who used to have fraction means a numerator over denominator, and the percentage is only percentage, and this is decimal. Here it is mixing. Sometimes he's using the same terminology fraction and he means the percentage or the decimal. Okay, just for your info. Okay, so the fraction of the woman in the population is 53%. We have either man or woman. Okay, so if the women are 53%, women are B1, 53%. So the woman will be the complementary, which is 0.47, because 53 plus 47 equals 100%, okay? Okay, so if this is 53%, this should be 100%. So 100% minus 53% equal 47%, and so. Okay, so coming to our problem. If you remember now the formula which we have taken in the last page, so his question here, what is the fraction of the people affected by the disease in whole population? So he wants all the people, whether women or men, okay, affected by the disease in the whole population. So he wants A, the people affected. So he's looking for the probability of A. Okay, this probability of A, and what he has given in the question, he has given the probability of A given B, probability of B given A. So I have to remember that this is marginalization problem. Okay, he is asking only for one of the margins, one of the element, and exclude the other one. Okay, so he is asking about one thing. He has given us a combined thing, event, and he wants us to have one event only. He asks the probability of A. Probability of A will be equaling, if we look at the previous example here, probability of A equals AB1 plus AB2 plus AB3 plus AB4. Here also, if we look at this formula, if you want to remember here, so the probability of A was equaling the sum of AB, okay, ABI. So probability of A, sum of A the disease which he is looking for, this will be constant and bi. So always we put a, this one, okay, a has to be put here, and bi, and this I will be I equals 1 up to, in our case we have only b1 and b2 up to 2, okay. So it will be equal a, the probability of abi. So from I equals 1 up to I equals 2. So probability of, you can see the probability of A, B, and first time I put I equals 1, B1, plus the probability again of A, again, B, this time I put I equals 2. Okay, next time I must put B equals 3, but here I have to stop at 2, so I cannot go to 3 or 4 or 5, because this is my end point, okay? So it will be the probability of AB1 plus AB2. This is the probability of A, okay? Okay, so probability of AB1. A, as we said, AB1 means the probability of A intersect B1, right? If you remember, okay? Okay. So we can write it in this way: probability AB1 equals the probability of A intersect B1, or we can leave it as it is. But we had an equation in the previous video for the probability of A intersect B. You remember we said it will be equals to probability of A, and replace this one by given B, times, okay, probability of B, right? So because this A intersect B is also B, AB, this one, okay? Both are the same. Probability of AB, it is probability of A intersect B, but different, just a different way of writing the notation. So it will be probability of A given B, okay, times probability of B. So we can replace this probability AB1 and the probability by this one. So let us try. So probability A equals probability of AB1 equals probability of A given B1, okay, times probability of B1. This is the first term, plus the second term, I write it here, plus probability AB2, probability of A given B2 times probability of B2. Okay, why I have thinking this way? Because I'm already having the probability of A given B1, so I have to convert all the problem to help me to use the data which has been given to me in the problem, okay? So I have converted the data to use the data which has been given to me, okay? So probability of A B1, I can get it from here, 0.4 times probability of B1, 0.53, plus probability of A B2, 0.06, times probability of B2, 0.47. Okay, so now let us just take it from here and go to the answer which it has been mentioned and the calculation in the example here, instead of repeating it again. Okay, so the probability of A equals the probability of B, probability of AB1 plus the probability of AB2. Probability of A is the sum of all the probabilities of A, which is related to AB1 plus related to AB2 plus AB3, AB4, the sum. Okay, so we can have it in this way, this one plus this one plus this one plus this one, or we have the sum function, any of them. In this case, okay, what he has done to answer this problem, it is the same way, just what we have done now. So he drew B1 and he said the B1 percentage, B1 is the woman, is 53%. He said B1 is 53. So B2 in the men 47%. Okay, so the probability here which he has, okay, it will be the probability of A given B1, it is B1 here already, and probability of A given B1, it will be 0.04. Okay, this is the probability, 0.04. So he multiplied it by the percentage of it. So how many people are sick? So how many women are sick? So I have 4%, okay? 4% of women are affected. So what is the percentage of the woman? The percentage of the woman is not 100%, so I cannot say it is 4%. 4% times the percentage of the woman. So it will be 4% times 0.53, okay? And for the men, it is 6%. 6% out of 100% or out of 50 or out of what? Out of 47%. So 6% times 0.47. You will find the same figures here. See, this is the one and this is the figure. So logically, you can do in this way. You can say, okay, we have 4% of women and the woman represents 53. So 4 times 53. This is the number of people or the fraction of the people who will be the woman which will be affected. For the woman, for the men, we'll have 6% and represents 47%. So the number of the men, the fraction of the men will be 6% times 0.47, and we add them together. But we actually here we are not solving it logically. We are solving using the formulas of marginalization. So we have to follow the formula. Okay, the probability of A equals the sum. If you remember the here, this is A, so it will be A, BI. Okay, starting from I equals 1 up to I equals n. Okay, so we start probability. Sorry, let me write it again. So the probability sum of the probability of A, okay, BI, and the I equals 1 up to I equals n, or I equals 2 in my case, okay? So it will be probability of A, B1 plus probability of A, B2 plus probability of A3, 4, and so on until we reach n, but n in our case equals 2, okay? So this is the same thing which he has wrote here, okay? Probability of AB1 plus probability of AB2. So then he replaced this one with the given, because we have already the given percentage of fraction here in the problem. Okay, so probability of A intersect A given, so A intersect B1, again I'm repeating. Okay, so it will be A given B1, okay, times probability of B1, and the same thing here, A, probability of A given B2, okay, times the probability of B2 again, okay. Okay, then I replace everyone. So probability of A given B1, probability of A given B1 here is 0.4 times probability of B1, which is 53, 0.53, probability of AB2 0.6, probability of B2 0.47. So the answer would be 0.0494, which is 4%, 4.94%. Okay. If we look at the answer, we'll find the reasonable, something which is logical, because I have 4% of the women. If all the population are women, so I have only 4%. I have 60% of the men. If I have all the men, all the population are men, it will be 60%. But I have combination, so it will be something between them. If I have 50% women and 50% men, it will be the average, 4% from here for the first half and 6% for the second half. So it will be 4 plus 6 divided 2 equals 5. But in reality, the percentage of the men is 47% only, and the woman is slightly higher, which is 53. So they're not 50-50, they're 47-53. So are very close to 5%. That's why it came 4.94. Even it makes sense. So I hope this one clarified all the issues related to marginalization, and we'll stop this video here and we'll move to the next slide.